So hello everyone, it's a great honor to be here. First time speaking in the stadium, quite impressive for me. Okay, so today we're gonna talk about Kotlin Ktor and how you can build strongly typed web services with this framework. And sorry for the voice, I lost it during a big football game a few days ago, so it's gonna be a bit harsh for me. Okay, so with introduction, so my name is Julien Salvi, as it was introduced before. I'm a lead Android engineer at Aircall, and I'm also an Android GD living in Paris. So part of the Paris Android user group, listening some punk music and drinking IPA. Okay, so what we're gonna see today. So I'll do a quick introduction about the Ktor framework, how to set up your first Kotlin Ktor project with the first steps, and how to build your first web services. Then I will introduce how you can build like a strongly typed web services with all the plugins, like connecting to a database with Postgre, Expose, and so on. You'll see there is a lot of nice tools to build strongly typed web services. And then I will end up talking a bit about Swagger to have a reliable contract between your backend application and your client applications. Okay, so first a bit of introduction about Ktor. So Ktor is a framework developed and maintained by JetBrains since 2018 for now. They released a couple of months ago the stable version of the 2.0, so now we are at 2.0.1 version. So all my sample will be based on that version, so it will be up to date. So also Ktor is an asynchronous framework written in Kotlin to build web services, web application, web clients, and more. So Ktor is a lightweight first. You can use many plugins as you want within the application. So with the version 2, they split it with a lot of plugins you can add just on as extra as third-party libraries. So if you want to keep it light, you can just add the core version of Ktor and do as much as you want. Ktor is also extensible. You can configure the pipeline itself, extend whatever you want, so it is highly configurable. And also Ktor is multi-platform, so you can use it on your mobile application, for your backend application and web apps as well. And the most important here is Ktor is asynchronous, so you can take advantage of Kotlin coroutines to build high scalable microservices. So that's a very nice advantage here to take advantage of the Kotlin ecosystem. Okay, so now we have like a bit of overview of Ktor. So what we're gonna run? So we're gonna build like a tiny web service. We're gonna set up some default routes. We're gonna see some plugins that will allow us to build a typed web service thanks to status page, resources, and ContentNegotiation. And then we'll see how we can discuss and connect with the database we have in local, so thanks to Expose. And we see another nice third-party library, which is Validator, in order to have a strong data validation for our payloads and requests. And then, as I said before, we're going to see a bit of Swagger. It will be our source of truth for the web service. All right, so let's see how we can set up a Ktor project. We're going to switch here to our fellow IDE. When you want to start your Kotlin application, your Ktor application, you might want to have a plugin maybe, but the fact is there is a plugin for the community edition, but it's now obsolete since the version 1.5.1 of Ktor. There is no other alternative within the IDE in the community edition. There is one, but for the Ultimate Edition, that allows you to have a plugin directly in your IDE and start to build your first Kotlin Ktor project. But yeah, it's only for the Ultimate Edition. But there is another way to do it. There is a website called start.ktor.io, and there you will be able to build your first project with Ktor. So let's see, Ktor sample for Kotlin. And there is also a bit of configuration. You can configure the website, the artifacts, the Ktor version you want. So starting from the 1.5.3 to the last one, so to the 0.1, you can choose the engine you want to run your backend. So let's stick to an AT engine, and then maybe we want to add a open configuration file, and then we can add some plugins, and there is a lot of plugins related to Ktor. So, for example, I can add I want to support a JWT token for my authentication. I also want to add some routing. That's by default. Location has been deprecated since the 2.0 version of Ktor, so I don't want to use it. Maybe I want to use some status page to handle some exceptions and so on. There's a lot of default things for content negotiation, monitoring, so we can use some logs, templating, and so on. There's a lot of things you can add directly through the editor here to create your first Kotlin application. And then, once you're done, you generate a project, and it downloads the application, like the whole package. You can open it with the IDE, and then you are good to go. Okay, so now back to the slides. Now let's see how we can build a strongly type web services with all the Ktor plugins exposed on Ktor. Okay, so let's say we want to build a recipe APIs. I want to post some recipes, get a list of recipes, getting ingredients, steps of the recipes, and so on. So these are some default routes here. If I want to get a dedicated recipe, I need an ID. If I want to post a new preparation step, so I'm gonna need a payload. So I need in this payload maybe a position, description, preparation time, and so on. So our mobile web app, whatever, will talk to our web service, the Ktor one, and the web service will deal with the Postgre database, and then the backend will send the response to the client application. But it's very interesting, and what we want to explore it's really the Ktor part here. So let's say we have this request here. So I want to post a new step for a given recipe. So in my route, I have my base URL. Then I have my recipes. Then the ID, which is a UID here, to identify which recipe I want to update. And then the step, because I want to add a new step for my recipe. So I have my payload here with a position, a description, and a preparation time, which is a JSON payload. So my request here, when it will be received by our Ktor application, there's going to be a route validation to say, okay, this is the right route, and the UID is right, and you're not sending it to like a long or an integer. There will be a payload validation to check that the payload we are sending is well formatted and respect all the constraints. And speaking of constraints, so there will be also constraint validation to say, for example, maybe a preparation time needs to be always greater than 0, and so on. Then in a cleanish architecture, so we're gonna map our entities to store them in the backend, and then to store them in the database, and then retrieve some from data from the database in order to send the response. So they're gonna be now a response validation to check if the format is good to go for the clients. And then, if it's all good, we can send the response to the client application. So, okay, so for all of this, we're gonna use these plugins and libraries. So we're gonna use resources for the routing, content negotiation, for negotiation media type and serialization. Status page will then handle the exception within the application. Validator for the data validation, and then a bunch of other third-party libraries for the data injection, talking to the Postgre database thanks to expose, maybe some logging, JSON library with Mushy, and so on. Okay, so let's first explore the resources plugin. So it's kind of a new plugin here introduced with Ktor 2. Back in Ktor 1 it was location, but now it's a bit deprecated. We'll focus mostly on resources here. So you can create type-safe routes. It relies on Kotlin Serialization. So if you are already using in your project, that's quite an advantage here. It supports basic types, integer, strings, Boolean by default. But we're gonna see if we need to use, for example, UIDs in your endpoints. We might want to use some Kotlin serialization tricks. Okay, so and then it supports all kind of methods: get, post, patch, delete, and so on. So we don't have these two libraries, so resources and Kotlin serialization. And this is how it looks like in the code. So we're gonna define a class, for example, annotated with app resources. So the base will be the /recipe, and then, for example, if I want to get a dedicated recipe, I also want to pass the UID to identify the recipe. So it will be /UID, and UID will match the parameter name within the Kotlin case. And as UID is not rate supported, we need to use Kotlin serialization to serialize the UID thing. So this is one possible approach. If you want to deal with a full pass, to say, okay, I want the recipe UID with my ingredients, identified ingredients according to a recipe, you can use a single class and define all the parameters you want in the class. So I was thinking about the UID. It's not supported, so we're gonna use Kotlin serialization to serialize the UID and deserialize if we want to decode and encode the value. So with this tiny implementation, you have the support of the UID type in your routing. So what you did once you have defined your route, so in the module application, you're gonna install the resources plugin with install resources, pretty simple. And then with the routing lambda, you're gonna define all the routes you want to support. So for example, here for the recipe routes, I want to be able to get recipes, post a new one, maybe patch a given recipe, and if I don't want a recipe anymore, I want to delete one. So I will make an extension function on the root and define all the routing I want. And then this is how it goes. So I will define the get, so I can access all the parameters within the application with the call.parameters. So if I want to support pagination and so on. For the post, I want to get the payload, so I call.receive and the given payload I want to deserialize. Even for multi-part data, if you want to upload a file and so on, you will be able to support the upload part with call.receive multi-part. Okay, so now we have defined our routine, which is type safe. Now we want to make sure that, for example, for the post request, our payload is well formatted. So here we're going to use Mochi. Mochi is a JSON library made by Square. You can deserialize data received from your request and serialize your responses. So it's very lightweight, no HTML escaping, and you can define your custom type adapter. And it's quite strict if you not respecting the model you have defined with Mochi, it will break and crash your application. So that's a nice thing, because we want things to be very strongly typed and reliable. And also it's used by the Swagger Gradle plugin, so keep that in mind. So this is how it goes. So we define, for example, to get the ingredient, get an ingredient. So I define my JSON field, and then there is my ingredient model. Pretty simple. So now we have defined our serialization, deserialization JSON library. We want to make sure that the data we are receiving, well format is done by Mochi, but now respect all the constraints we want within our application. So respect all the rules that our backend have. So we're going to use validator here, which is an external library. So for data validation for your request, there is a type safe DSL to validate all your objects. It has a nice support for suspending function, so you can validate things that depends on coroutine, suspending function, and so on. And there is multiple extensions. You can use Spring, Joda, and so on. Okay, so let's say we have our payload coming from the step we want to add to our recipe. So we have our position, the description, and the preparation time. So nothing can be null here, and it's defined. It's a long. The description is a string, and the preparation time is a long. So this is coming from the Mochi model. And here we're gonna validate this model. So once we receive it and pass the Mochi validation, so we're gonna validate the post request and say, okay, the position must be not null, but it has been already validated this part by Mochi, but just in case. Also, the position must be greater or equal to 0. For example, also the description must be not null and not blank, and so on for the preparation time, not null and greater or equal than 0. And if one of the rule is breaking, we're gonna throw a constraint violation exception within the application. So once we receive our payload in our endpoint, so getting the request and the payload, I will call my request.validate in order to check that the payload is respecting all the constraints we want. So, as you know, I was throwing an exception to say, okay, if there is a constraint violation, I will throw an exception to break the things. But we need to handle this kind of exception. So now we are validating our payload, request, route. But if there is any kind of exception, it will break your application, but the client part must be notified. So thanks to status page, another Ktor plugin. So if you want to use it, you have to implement this library in your Gradle file. So status page will properly handle errors and exceptions in the application. So there are 3 types of configuration. You can handle exceptions, status, and status file. And it's very simple to implement. So again, in your application.module, you're gonna install the status page plugin and then define the exception functions, which is an extension on the status pages configuration. So here we're gonna define, for example, 2 exceptions we want to handle. As I said, I was throwing the constraint violation exception. So every time this exception will be thrown, I will handle it and say, okay, what was the constraint that were bad, and then I'm gonna send a response to the client part to say, okay, I want to well-form this response. This constraint was not bad and not respecting this kind of constraint and so on. And then I can also handle any kind of exception, like to say, okay, there is something wrong, and I will send an internal server error and so on. I can also catch the status, say, okay, every time there will be a 4 or 15, whatever. I can catch it and send a dedicated response here. So now the client will be aware of what's wrong and what it did wrong with the payload or the request. Okay, now we are done on the API front part. So all the root, payload, and so on are validated. So now I will show you how to deal with the database, with the Postgres database, for example, and use expose to deal with the database. I will skip the part of how to connect with Docker and so on, because I use a Postgres database on local that is running on a Docker Compose container. That's not the main point here, but on the behind, we use Docker Compose and Postgres to have this database. But I will mostly focus on expose, so we can retrieve and add new things in your database. So expose is the ArenA framework built in Kotlin by JetBrains. It supports Postgres, MySQL, H2, MariaDB, and so on. And also there is the data source with the GDBC connection we can use. Here I'm going to use a recipe to do it. So the API itself you can use a DSL or DAO API to query the database. It supports basic and advanced operation and the basic CRUD operations. Okay, so once you want to deal with export, you must have these following libraries in your Gradle build. And then you're gonna define all the tables and entity you want to deal with the database. So for example, here I want my recipe table, which has a description, a title, and a cooking time, for example. So I'm defining the table, and then I will define the entity I will manipulate with the ORM. My recipe entity will depend on the recipe table. It will have accessible the title, the description, the cooking time, and it will have some reference. So a recipe has some steps, and a recipe have ingredients. So we're gonna use here the word reference with an infix function that will have a reference on the step table, which will have the recipe here. And it's mostly the same for the ingredients. We're gonna use the keyword via to have the reference on the recipe ingredient table. So I was speaking of the create operation. Here's how you can manipulate the basic operation. So to create a new recipe, you call recipe.new on the recipe table. So in order to create a new recipe with all the parameters. To get a new one, we'll call the recipe.find by ID to update a new one. So I'm gonna find this recipe and update the field I want. And then if you want to delete a recipe, you can go and find the recipe and then call the delete. Okay, so what about transactions for now? If you want to chain transaction, have a bit of asynchronously in your application. So the basic transaction will be to call the lambda transaction, which is not coroutine friendly. But if you want to use your application within coroutines, you're gonna call a new suspended transaction, and then it will be coroutine friendly. Or you can use the suspended transaction async and pass the dispatcher you want, and then get whatever you want. For example, here I want to find the recipe and the ingredients of the recipe, and then I'm gonna map these entities to the entity that will be sent to the front line. Okay, so we see the create operation. We saw also how you can make transaction, and now let's see a bit of the referencing. So you have the many-to-one relation. So for example, on the step table, a step has a reference to a recipe, for sure, and also it might have a reference to maybe a video. So if the reference is optional, you can call the .new label on the reference, and it will be present or not. And then on your step entity, so the recipe will reference on the step table recipe, and the reference of the video will be optional. So we're gonna call the optional reference on. And then also on the recipe, so the recipe will have steps, and steps will reference on the recipe table and the step table. And then there is also the many-to-one relation. So here we have the recipe ingredient table, because a recipe can have ingredients, and also ingredients can be in many recipes. So here we're gonna define a recipe ingredient table to match both and have recipes and ingredients. So once we define this table, on the recipe and ingredient table, we will use the keyword via to add this reference on this recipe table. Okay. So now we have all the things to build our strongly typed web service. And now we're gonna see how to use Swagger to build a reliable contract with your clients. So Swagger, it's a Gradle plugin to generate network code from Swagger. It was made by Nicolas Corti. Swagger relies on Open API, which is for RESTful web services. Support YAML or JSON to build this huge configuration file. So with this file, you can generate retrofit interfaces for your Android app, for example. It will use Moshi to define all the models you will be define for your client, but also for your front API models. It has a nice also Kotlin Ktor support. So this will be our source of truth for our backend. So here is the module within our project. So we will focus on here. So once we have generated all the models, it will be on the build folder when you can access all the models and the retrofit APIs you will be using for your Android application, for example. So this is how you can define in your Gradle file. So we define the CodeGen plugin, and then we're gonna define the Gradle task to generate the models. So I want to use the Kotlin coroutines as a support of it. I'm gonna define my package name and see where the YAML is located and where I want to put these models. And this is what does it look like? So this is the Open API, the Swagger file. So here it will be my documentation for all the endpoints I have in my web service. And again, it's only type, so if it's required, it must be notified. And then, for example, to get a recipe, I need, like in the past, it will be a string UID and it will be required. I want to get a recipe, so I will be define the recipe model. So which type and so on, what is required and what is not. So this will be the strong documentation for the client and the backend. And so once you run the Gradle task, it will generate the retrofit interfaces and the model which are based on Moshi and where you can use it on your client and on the backend side. But the thing is, on your backend side, it will use like zone data type, but it's not quite supported. So you might need like to handle some data type on your own, or you can add an improvement to use Kotlin Serialization. So to sum up about the Swagger Gradle CodeGen, so you're gonna build with it all the front models for your backend and all the remote models for your Android app. And all these models will be the same. So no more object type surprise. It will be strongly typed, you cannot make any mistakes. So it will be a very strong contract between your clients and the API. But there are still room for improvement here. For now, there is no Kotlin Serialization and data type format support, so things can always be improved. Or you can build your own Gradle plugin using like maybe directly Open API and so on. Okay, so now we have like an overview. Let's switch to the IDE and have a bit of a live demo. So here is the web service I built. So I'm using resources, Coin for the dependency injection, ContentNegotiation, so it will be my JSON serializer. So it will be Moshi here. I'm gonna handle some status exception here, for example, what I say, constraint violation for validator, and if there is anything wrong on the JSON part, I will catch also the JSON data exception in order to say, okay, there is bad format or dispatch the message. Then, so I'll define all the plugins here, define my route. So here, for example, I define all the routing stuff for the web service. So I'm gonna get all the recipes. I'm gonna be paginated, so I'm gonna access the the page parameter here. So I want to check the page and the count. So then I'm gonna talk to my service, say, okay, my repository, I want all the paginated recipes. And here in my repository, I will talk to the database to get, okay, I want all recipe order by the creation date, sorting by desk. Then I want a limit because I want things to be paginated, so I will stay with my page and offset and so on. I will then map the entity to send the data then to the client. Okay, so if I run this sample here, so running configuring the project should be within minutes. Okay, now so the database was already running, and if I go to if I go here, so you see that the service is running, but not very pretty. So I'm gonna use Xebia here. It's kind of a postman-like, if it's fine or not. Yeah. Yeah, come on. Okay. Okay, so here's the check. So here you have the service is running. It's good. I'm gonna get all the recipes. So I'm getting a 200. So I have a list of given recipes here. Can get, for example, this one is pretty. Okay, if I have this one, I will get all the details about the recipe. But if I mess up with the entity, the routing stuff, okay, there is no 83 thing. It will send like an internal server error. For example, I can create also a recipe, a new one. So let's say it's some recipe. I want to say, okay, global description, but I put like -36 as a cooking time. If I send the response, the request, so I get a response that say, okay, unprocessable entity, because the recipe cooking time must be greater or equal than 0. So it will, for here, it has break the constraint. And for example, if I'm not, if I send like, okay, a string instead of an integer here, it will break the Moshi part. So the model won't respect all the constraint made by Moshi. So here, unexpected hit, but on the recipe cooking time, it was a string. And so here, if I want to add like a new recipe, say cooking time 80, and this should be all good. And we have created a new recipe. And then, for example, you can add like a new step. Say, okay, I want to say step 5, and so on, and so on. Okay. That's it, pretty much it. Thank you very much for your attention.